question 2. We got this function f of x and we're given the factors. So that means it's been factorized. And now we're using these factors to sketch the curve. So that's okay. But first, we need to turn the factors into roots. In order to do that, we need to set each one of the factors to 0. So we set that to 0, set that to 0, and set that to 0. Now that we've set them to 0, x equal to 0, so that's one root. Here it is, x equal to 0. X equals to minus x minus 1 equal to 0, therefore x equals 1. So there is x equals to 1. And 2x plus 1 equal to 0. Subtract 1 from both sides, divide both sides by 2, x equals minus a half. There is x equals minus a half. So now what we need to do is that we know the roots now. We can just get the curve from the third quadrant. Why? Because the degree of polynomial is 3, the highest exponent is 3, and it's odd. If it's odd, this is the third quadrant, that's odd. Now first, we draw graphs from left to right. This is even, this is second quadrant, and this is odd, this is third quadrant. If your polynomial is odd, you start from the third. If your polynomial is even, you start from the second quadrant, provided a is positive. If a is negative, the reverse is true. Now I want to show you how to find the maximum here and the minimum value. The way to do that is to multiply out the factors and get the proper function. Once you've multiplied out, I'm going to get a function like that. And then I'm going to differentiate our function to find the gradient, and I'll set the gradient to 0, and that will give me the value of x here, because it will be quadratic, and I'll get 2 roots, and that will be the values of x. And then I plug in the values of x back into the function here that I've multiplied out, and then I'll find the values of y and tell them the values of y and the values of y. So what I'm doing first is multiplying the x by this first factor by the second factor. So I get x squared, x times x is x squared, x times minus 1 is minus x. And then I'm going to times this factor here with a third factor. So now that I've multiplied these two together and I get that, I actually get 2x cubed plus x squared minus 2x squared minus x. So then I'll simplify these and I get that. Now I need to differentiate this function. Now if you don't know how to differentiate, I'm going to write down the formula I'm using. So we use that formula and we differentiate. This is a function and this is the differentiated function. How I'm doing it is, if I have a x to the power of n, then the differentiated will be a times n. So I bring the n down, x, n minus 1. So now when I've differentiated that, I got this. How does that happen? Well, you can see I did 3 times 2 is 6. 3 minus 1 is 2. So that's 3 minus 1, that's 2. 3 times 2, 6. Now for the second one, 2 times minus 1 is minus 2. That's 2 times minus 1. That's it, minus 2. And then 2 minus 1. 2 minus 1 is 1. So that's 2 to the power of 1. Just to bear in mind, x to the power of 1 is still x. And so when I differentiated that, that would be 2 times minus 1 is minus 2. And then 2 minus 1 is 1. Therefore, x to the power of 1 is x. Now this one is x to the power of 0, x to the power of 1. Because this is 1 here, I do 1 times minus 1 is minus 1, right? Then 1 minus 1 here, that's 1 minus 1. I get x to the power of 0. X to the power of 0 is 1. So 1 times minus 1 is 1. And that's the differentiated version. Now I need to solve this quadratic equation. I'm going to solve this quadratic equation using my calculator. Okay, so this is a function. And then after expanding them, we go to here. and then I differentiate that using this formula and using that, and so we got this, which is that. Now I'm going to use a calculator to solve the quadratic. Start your calculator and then press menu. When you press menu, you can press the arrow forward to A or press the arrow back. Because I'm going to A, the arrow back is quicker. The calculator goes from 0 to 9, and then 10 is called A, 11 is B, and 12 is C. So it goes 1 to 9. So if we could go all the way to 9 to 10, or we can go back to 10. So going back is quicker. C, B, and A. Now when you get to A, press equals, that's enter. Now because we're solving a quadratic is polynomial, so you select 2. Now because the exponent is 2, the degree of polynomial is 2, so that's what they're asking here. Is it 2-degree polynomial or 3 or 4? This is 2, so there you press 2. Now you can see a quadratic expression. Now you can enter A is your 6, so you'll put 6, press equals. B is -2, so you press -2 equals, and C is -1, press -1 equals. And now the next equals you press will be your x value, so you press equals again. So the first x value is 1 plus √7/6, and if you press standard or surd to decimal, you get 0.607. That's your first value. And the second value, press equals again, you get 1 minus √7/6. And if you press standard to decimal or surd to decimal, you get minus 0.27429. If you want to come out of it, all you need to do is press shift, reset 9, then 3 equals AC. So that takes you back to, and then it clears your memory. So x equals 0.6, and the other x is x equals minus 0.27. So this point here is minus 0.27. And this point here is x equals 0.6. So now I need to plug those values in to find the y values. So after finding the values of x, and then plug those values back into the equation here, fx, and I get fx equals to minus 0.53. So for 0.6, I get minus 0.53, so that's my turning point here. You can see that's a turning point, because if I'm coming here, I've got to turn here, and so when I do x equals to minus 0.27, which is here, and the y is 0.16. So I'm turning at 0.16, so I have to mark that, and then I can turn there, go through my roots, and then coming down, and the next turn here is the minimum, which is minus 0.53 for y at x equals to 0.6, and then turning back up again to go to infinity. So this one goes all the way to infinity, and that comes from negative infinity. And that's how you sketch the graph.